Abstract classes. So an abstract class is used to implement common features of related classes. So it's declared with the abstract keyword. If a class has at least one abstract method, then the class must be declared abstract. Also, abstract classes may contain non-abstract methods and variables. You cannot instantiate an abstract class. That means that you cannot create the object of it. So in order to use abstract as a class, we have to inherit it from another class. So you can think of an abstract class as like a template. You must extend it and override the abstract methods. An abstract method is also just a prototype. So it has no body and contains the following attributes: a return type, a method name, and a list of parameters. Methods and members of an abstract class can be defined with any visibility, such as public, protected, private, etc. So in our example, vehicle is an abstract class that contains only one abstract method. Get max speed, right? Remember, it's got no body. Because the implementation of this method is provided by the car and motorcycle classes. You were wondering why that was empty, huh? No body. So the car and motorcycle classes have to override the abstract get max speed method of the superclass vehicle. Okay, so I heard a couple of pennies drop. So let's do some examples and we can understand the abstract class a little better. So in the Object-Oriented Programming project, right-click on the source folder and select New Class. Specify the package name as Abstract Class and the class name as Vehicle, and choose Abstract to create the abstract class. The vehicle class is an abstract superclass. So let's declare two instance variables that are named type and model with the string type in vehicle class. So let's declare a public constructor that's named vehicle, and it contains two parameters, type and model. Now in the constructor method, we can assign a parameter variable, type, to the variable type of this class. And then we assign parameter variable model to the variable model of this class. And now we can use the this keyword to access the same class variables. Now let's declare two non-abstract void methods in the vehicle class. First one is public void start. And then we print the message vehicle has started by using our print method. So the second one is public void stop. And then we print the message vehicle has stopped by using the print method. Now we can declare an abstract int method that's named getMaxSpeed with no body. And now we must implement this method in the subclass. And here's where you remember to save the code. Okay, so now we're ready to create a new subclass. So just right-click on the abstract class package and select New Class. and then specify the class name as car. Now our subclass car extends the abstract superclass vehicle. So this means that the subclass car inherits all the methods and variables from the superclass vehicle. But wait, we get a compilation error. So what do? We just place the mouse on the car class and Eclipse shows us the quick fix dialog. So we defined a constructor in the abstract superclass vehicle. So that means we must define an explicit constructor in the subclass car. And we must invoke a superclass constructor from this constructor by using the super keyword. So we can add the constructor by selecting the Add Constructor in the Quick Fix dialog of Eclipse. And look at that. Eclipse auto-magically added the constructor with the super keyword. Now also, if you go back and place the mouse pointer on the car class, Eclipse will show us this quick fix dialog. So we must implement the abstract method getMaxSpeed in the car class. So we select the Add Unimplemented Methods, and then Eclipse automatically added getMaxSpeed as a method with the override annotation. So let me give you a little bit of history. Way back in Java 5, annotations were introduced. So an annotation always starts with the @ symbol, followed by the annotation name. So whenever you override a method of a superclass, it's always best practice to include the override annotation. The override annotation is also used for making code readable as well as avoiding any maintenance issues down the line. So now that we're having fun, let's override some other methods of the superclass vehicle. Now there's no obligation to override non-abstract methods of abstract superclass vehicle. So let's copy the non-abstract methods of the superclass vehicle, and let's make some changes for implementing properties of the car class. So we use the car has started in the start method instead of vehicle. And we use the car has stopped in the stop method instead of vehicle. So let's add the override notation to these methods. In the getMaxSpeed method, we declare a final variable, max car speed, in uppercase letters, and then assign this variable to 320. Now, it really is good to get in the practice to use final variables using all uppercase letters and underscores as a separator. So now we print max speed of car by using the print method. And then return the variable max car speed. Remember to save the code. Now let's create a main test class that's named abstract test in the same package. So in the main method, we create a car object by passing parameters. The first parameter, car, represents the type of car. The second parameter, Ferrari, represents the model of the car. Now let's call the overridden start and stop methods from the subclass car. And let's call the overridden abstract getMaxSpeed method from the subclass car. Okay, so let's run the code. And you can see the results right here in the console. Overridden start method was invoked, and car has started is the message that we see displayed. And then the overridden stop method was invoked, and the car has stopped message was displayed. And then the overridden abstract get max speed method was invoked and the max speed of car is 320 message was displayed.